Hello there. This is a quick demo of the Axon C2 command and control platform, some sort of proof of concept. So Axon C2 is a software product that allows multiple teams to monitor and control different fleets of embedded devices and autonomous products from virtually any part of the world. For this demo, I'll be streaming sensor data from PX4 simulations of autonomous drones over UDP network to a Flask backend and ultimately to a React front end. And for this, I have set up a headless simulation of 3 autonomous drones with PX4, and also I'll be visualizing that with Gazebo GUI. So here we have 3 instances of the PX4 drones within the GUI, and just to visualize their motion, I have also set up a Commander Python script which basically sends random waypoints to each of these drones. So we're going to start that script now. We can see it's connecting to each vehicle, and we can see each of the drones arm. So the drone 1 is arming right now, and it's going to take off. And we see the same thing happen for drone 2, that's taking off. And finally, drone 3 has also taken off. And just to save CPU resources, I'm going to close the GUI right now, and we're going to go into Wireshark. So Wireshark helps us to monitor the health of the packets and the content of the packets that has been streamed from the headless simulations over the UDP network. So we're starting Wireshark right now. And as we can see the MAVLink data, we can see altitude, odometry, altitude, GPU raw int, and several other common PX4 MAVLink data. So now we'll close Wireshark and we'll come to our Flask backend. So we're streaming the data, and we've configured a MAVLink parser to intercept that data, the UDP data, and process it. And all of that is being done by a Flask backend. We're going to start that Flask server right now, and we can see that the MAVLink initialization is complete. The next thing we're going to do, okay, for now, let's stop the Commander as well. And next we're going to do is to load up the React front end. That's going to load up right now, waiting for GPS data. And as you can see, that's all up. But because we abruptly stopped our Commander script, we can see that each drone right now is in critical status. Now, let's change that by restarting the Commander script. We're going to restart that, and we can see it's connecting to each vehicle. That's all loading up. It's going to take a while, but we'll go back to the front end, and we're going to see all of that data change. So we're going to see each of the drone go from critical status to active. It might take a while. It's going to disconnect first of all, and then reconnect back and start streaming all that data to the front end. So it's still at critical. Okay. And so we can see it's gone from critical to active, and immediately we see the first drone take off, and we can see its movement. We see that happen also for the second drone, and finally the third drone also goes from critical to active, and we can see all of the movement right here. Also, we can monitor several network metrics like latency. We see latency for each drone with different colors. We see jitter, and we can also see update rate. And we can also monitor each metric for each drone. And we can see the jitter here as well. And overall, the average latency is just right under 3 milliseconds, which is great. We can also see all the packets that is streaming for each drone, and also the total packets and the throughput as well. If we want to shut this down, we can just disconnect, and we can see it says waiting for GPS data, and all the metrics go off, and then we can reconnect once again. Now, this is just a quick demo. In the future, we're going to have AI inferencing. We're going to have live video stream from each of those assets, and then we're going to be able to do several other things through our distributed system. So that's all I just wanted to demonstrate for now. Thank you very much. Bye.